Swayam Prabha. Digital India. Educated India.
In the YouTube, please ask your question. We already are there. Professor Shumana Gupta and myself, Professor Shankarpati Bhattacharya, and our two TAs, teaching assistants, Tania and Monali, all are here in this YouTube live. So if you have any queries, you are now free to write any questions till our last 4 weeks. We will try to answer them, we will try to address them.
Yes, students, I welcome you to this live session. And yes, Tanush, you please write your doubt.
It has a delay. It has a delay. Long delay, Shumanadi, it has a long delay.
YouTube link is lost.
One has raised a question that the sound decibel meter to read. We have sound decibel meter to read the dB, but how do we read the sound in empty room, or how do we check the absorption coefficient in room? So let me answer that one. Let me mute this first. let me answer this one. Decibel meter alone, only one decibel meter cannot going to help you. Actually, you have to find out the reverberation time in a particular room and test panel and all, which is you require a very dead room, which is having very less reverberation time. And we can, without the proper the test material, test panel, you can actually find out the difference in decibel, and from the difference in decibel with the dimensional character of the room, you can find out the absorption coefficient of your test panel, or the average absorption coefficient of the all the surfaces which you have rendered in that room. So if you can go to the room acoustics lecture just after the reverberation time, there was two formulas given in that particular PPT or in the lecture. You can see that how it can be done. So the problem was solved if there is a additional panel coming, or if there is a panel coming over a particular existing wall, how the equation changes and how to find out the reverberation coefficient. See, if there are different material in the room, then it is very difficult, because you have to go for a one after another. Suppose you have 3-4 material to test, so you first know that what is your room total absorption, and then one after another you can test and find out the alpha or inertia value of the different material. All at a time you cannot put all the three, and you cannot get the reversion, the alpha value of the all the three. Okay.
Where is the button for muting the? We are in the YouTube. I will just put it. Is it closed now? Is it okay?
See, there is a question from Meenakshi Sharma. She is asking probably the same question she was also asked in our Google Sheet, that she want to know that how we can design the soundproof room such a way that it can act as a home theater kind of a scenario. Of course, you also asked for it is low cost. Home theater itself is a costly affair, and you need some typical dimension of the room dimension and all. It's not going to help you if the room dimension is small also. But at least you should see the machinery wall, which is all around, which is good reflector, no doubt about it, but it will be going to stop the outside noise if it is a machinery wall of typical 10-inch thickness or so. But you should actually provide lot of absorption. One way it may be of very heavy fold curtains in the windows, and you have to see the windows, it is properly sealed or not. You can go with the double glazing windows, which will be also beneficial for your sound isolation from the outside. Window is one of the leak point, the leak point. So you have to first take care of that to stop the outdoor sound, which is required. The second one is that internal absorption have to be increased. So you can have heavy fold curtains, carpets, then as much as less amount of wooden furnitures. You may have some kind of the fold, heavy fold sofa or chairs, and you can treat the rest of the wall with some kind of a panels, which is absorptive panel, maybe a panel absorber or maybe porous of kind of a absorber. Instead, you can go for some acoustical paint, which will be nice. If the room height is bit more, you can think of some maybe around 1 feet or 1.5 feet false ceiling. The door should be also looked into, because there may be a noise leak from your balcony door or maybe from your other door, which is associated with the corridors and all. You can go for double leaf door, panel door, and you may have glass wool in between the two leaves. That will boost your TL capacity, that is transmission loss. So that transmission loss chapter will come in the last part 1, as our 7th chapter probably, we will understand better. So in nutshell, it is like that. Professor Shumana Gupta may add a few points.
Yeah, Professor Bhattacharya, right. Actually, we haven't covered all these. We have covered the spaces, I hope, in the module 4, where we had discussed. Recording room, is it discussed till now? I think it is not. So when we will be doing recording room, you will find some similarity with what Professor Bhattacharya was telling. So you have to absorb the sound as much as possible and also look into no noise, vibration and all related sound that is adulterating the system, because you are trying to have a home theater system within your house. So you have to keep that in mind. The key point is minimum of noise entering and adulterating or disturbing the true sound which is of your concern.
So let me take another question from Abhali. Okay. The existing acoustically treated room, and I want to check if the acoustical treatment is done correctly. How do you check? That is number 1. So it's better to check with proper electronic instrument and check the reverberation time in various corner of any room. And for that you need the graphics analyzer or the sound analyzer, how the sound is going to drop and how the sound is actually going to build and all. So there are instruments which is available which can give you directly the reverberation time without going to that much of complicated detail. So you have to purchase those, and you have to actually find out in different locations what are the various the reverberation time. It is also good if you do this particular checking or this particular measurement in when a live telecast or live performance is going on with full audience or maybe some partial audience, because the character of the reverberation time will entirely change with when there is sound systems and when the audience the auditorium is full of audience. But the way you have to check, you have to go to the remote corner, you have to go to the very middle point, you may have to go to the very front seats and check maybe at randomly maybe 5 to 10 points of your interest, if it actually goes as per the scale of your auditorium.
Now Are you over, sir?
Yes, madam, you can also.
Okay, so actually when as Saras, I would like to add to that is you are designing the room for to achieve a particular reverberation time, and that depends on the performance which is going to happen in that space. If it is, say, it's a multi-purpose room, then you will have to achieve a particular reverberation time based on which you have done the treatment. Now, as sir suggests that a room can only be checked when it is fully occupied or at least 80% occupied. So with that kind of live session carried out, also the volume of the room, all these things when you account for and then you work out, you can find out whether you are complying with the, whether you have done the acoustical treatment rightly or not. So unless and until that is happening, and you have to take the note of the reverberation time from various points and not only sitting in one point, obviously the sweet zone and all those things, rather you have to move to the most remote corners or come to the front and take the measurement, and there you can find out whether you have achieved your goal, that is the target RT or not. So that will help you in finding. Again, I think you have a question. You had mentioned NRC value is specified on the material. Is the absorption coefficient? The alpha mentioned 2. That means, or do we have a separate machine to check the absorption? No, the NRC value is quoted, is given. That means it is the alpha value to carry out the calculation. That is the average of the average value of the different absorptions at 250, 500, 1000 and 2000 hertz. So that is the average, and that has been given as the alpha value of that material. So you don't need a separate machine to again recheck it. If it is quoted, that you may go by that value. You may consider that value for the calculation part. Thank you. Another question by Meenakshi Sharma. What is that? Thank you for answering, sir, ma'am. Room size is 20 feet by 70 feet high, is 10 feet below beam. Taken provision by giving smaller size window opening. Are these acoustics paints effective in terms of cost and longevity? Is it your room size 20 feet by 17 feet and 10 feet below the beam?
Can I answer that?
Yes, yes, please.
That I think the same lady is asking the question, and that room size is quite big. 20 feet by 17 feet is the dimension, and the 10 feet is the below beam is the height. So that's a quite big room, and she's also mentioning that there are small windows. You have to treat it properly. That what the madam also told, I also told. And acoustical paint effective in terms of cost and longevity, I may not directly answer that, because what I have idea is that acoustical paint required to be actually go with very skilled labor. The workmanship is very important. As such, it is a cement based paint, and but you have to look very carefully that whether it is if there is any moisture movement, if there is any kind of the moisture propagation and all, it may show efflorescent in the due course of time, and there may be some kind of patchwork and things may come out from the actual things. But those are all uh, those are all very the workmanship problems and all. It is better to actually go to the market and talk to the actual people, those who apply those things. There is another question asked little earlier. I think we have missed that once. That one
Of a
is
panel. There is something of a panel or brick or concrete
no,
block you
no,
have. Okay.
no. Can you name the? I just let me highlight. Can you name the instrument to
Oh, for
calculate
active.
the RT, please, the reversion time? It's actually come under the category of the audio analyzer. So it is not only a instrument that gives you only a RT, because you know the RT is also a function of the audio quality, that is the frequency and all, frequency at least. So the audio analyzer, you can in that umbrella there are a lot of electronics instrument or gadget available in market, so you can actually go through that. There are various products, there are various companies, those who actually come into this field, all the electronics, the devices and all. So they have different brand name, and finally it is audio analyzer.
Yeah, again coming back to Meenakshi's question, like you have a room size of 20 cross 17 into 10. Basically, it is a large room, and as sir also raised the point, it is going for, you are going for painting. I would advise it is better to go for such room for the conventional treatment, because one is effectivity of such large space. Putting acoustical paint may not be very wise decision, and as because there are problems coming out of that, and you have 17 feet cross 20 feet, so you can go away with few inches on the sides and put some paneling and get your acoustical, means you get your acoustical treatment to your satisfaction basically, instead of going for paint. See, I have gone through the question of Abhali Gora. See, if you are doing some precise calculation, if you know your target frequency, then you have to work with the absorption coefficient of that particular item. NRC is the average against the from 250 to 2000. So that alpha value is the alpha value is the average, but not all material are as good absorbers for each of those particular frequencies. So that is why the material has been covered separately, to make you understand that going by average NRC value can give you a good estimate of the material you will require. But if you know exactly what is your target frequency, what you need to, which sound you need to actually help in dying down, then it is better to go by specific values of whatever alpha 500 if you want to track, or alpha 2000 you want to track in case of musical. In case of it is only a space for speech delivery. So there the frequency that will be originating will be will be around 500 to 1000. So you will have to look into material which will absorb maximum of that frequency. So NRC value gives you the average value, which will be okay for all multi-purpose application, but may not be for some specific application. So when you are planning for a musical concert, you have to look into when your absorption will be at a higher frequency, but not 250. So that is why the material basket is clearly explaining that NRC gives you a very good very good platform of knowing the material and suggesting a material. But if you know what is the specific purpose, because not all halls are designed for as a multi-purpose. Very few specialized halls do come up where very high-end performers are working. They are exactly those frequencies are to be trapped. So then comes the role of the material selection. Okay, so that is why, so it is not a confusion, it is an add-on basically, or a precision towards working out the reverberation time. Costing is the issue we are looking into. So, you are not audible, please. Professor Bhattacharya, unmute yourself.
Can I add to that question of this NRC?
Yes, please.
What Madam told is absolutely okay. And see, the in case of the any auditorium and all, you please go ahead with the NRC value. That is it, which is the average value of 250, 1,200, and of course the 125. And because in auditoriums it is general. Suppose a particular day there is a dance drama, and then the next day there is a kind of some talk show, and then maybe there is a very the high-end kind of musical program. So if you see that, suppose there is a high-end musical program, the artist comes with their all live, the technicians and the engineers, the sound engineers, and they will take almost 2 to 3 hours time before the live show starts, and they check everything. So they take care of the problem that exists in that particular auditorium of some high frequency or any frequency through the electroacoustical system. They check. They take 2 to 3 hours. But other performance are normal performance. So there you better go with the NRC. And if there is any specific use, suppose there is suppose the radio jockey, or maybe some kind of a talk show studio, okay, or maybe those, or maybe the telecasting room. Those are all speech. So you need to have the mid frequency stronger. Then you may actually look into the 500 frequency, 1000 frequency, the alpha values. I'm not telling now NRC because now it is alpha values. Suppose it is a particular studio specially made for the singing and some music, then you have to go a little higher, 8000, 4000, 8000. So now you look into the alpha value of that particular material. So you have to go to the absorptive material, which is preferably for the high frequency. Madam already has told you in the lecture, in the material lecture, porous panel and the resonator absorbers, they have different type of the character and different type of the absorption coefficient in different frequencies.
Can the students see our chat box, our Zoom chat box? Professor Bhattacharya, can our students see our Zoom chat box? No.
Yes, Zoom chat box is available with all of 5 of us.
To them, not only 5 of us, or
only 5 of us. Zoom chat book is only for 5
so here
of us.
we can write any, means we cannot write anything related to students.
YouTube chat, no.
Okay. See,
That is
Abhali
internal.
Bora has some more questions again. While designing a space conference room, if it is a glass cabin, how to treat it? Good. how to treat it? See, you are having only left with your ceiling and your floor where you can do some treatment, and I don't know if it is entirely glass box, means then ceiling. So you have to see what was the purpose of, how would you, what is the purpose of the conference room? To carry the sound towards the, from the speaker to the furthest listener, isn't it? And that is why you had created a reflected ceiling, and to bring, not to bring back the long delayed reflection from the ends, you had absorbers on the other parts of the ceiling as well as the wall associated just after the ceiling. So those were all treated with absorbers. Now, if you are planning for entirely glass, glass will obviously reflect the sound. So you are left with the ceiling where you need to absorb it more, and it should not get reflected to the glass, or so you have to weaken the reflected sound at that point. And you can even adapt some shape so that your sound does not come back to, or comes back as a late reflection to the audience or to the participants in the conference. So ceiling treatment and floor treatment, other than that, floor is always carpeted usually in case of conference rooms, so that keeps away the floor sound also, the foot sound also that can be generated. You can have heavy curtain walls to cover your glass surface, otherwise it is open, or at times of conference it can be partially pulled, and you can actually treat your wall in an indirect way.
Can I add to that?
Yes, please.
So what madam says, with that I'm just adding, once I went to Mysore long back, and I was with my students to a visit in Wipro, or maybe Infosys or whatever, their conference room, which is totally glass as you told, and it is, I have seen that with our some engineers over there in their maintenance engineer, it is a double glass to shield the noise from outside. And what they told is that they are the practical people, they actually went for the installation and all. In a conference room, or it's not a conference, meeting room kind of a thing, office meeting room for a 30-35 people, those glass things will not going to be a problem. Only if you treat the floor with carpet and some portion of the wall with some wooden things and the reflected ceiling and all, it's for good. But if it is more, then there is a reachability problem, and this, the loudness, the decay of the loudness and those things will occur. So what I can say, within the 30 people meeting room, it's not an issue at all. The glass partition, the glass door, sorry, glass wall, if you treat the floor and ceiling well.
So I'm just interested, like Meenakshi Sharma, you are giving the area of the conference room 21 feet by 13 feet and 8 feet high. So if it is the room dimension, then 13 feet by 21 feet, as sir is telling, it won't be a big issue to transfer sound from one end to the other. So 21 feet means it will be having some circulation space of 3 feet. So it will be around 15 feet. So it is as good as talking in a living dining room from one end to the other. So I hope sound won't be an issue, and that too with a height of 8 feet. That is, the distance traveled will be much less. So sound will hopefully reach well with energy, with its energy to the other end, so that one is audible. Yes, Meenakshi, I found that you wrote yes. Good. So it's good that you are asking with dimensions. That gives us the clue that whether it is doable or not. And you also, do we think of acoustics so much in our day-to-day life? No. We are more interested in, say, from the classroom size. We had started our discussion when in our lectures, we started from classroom, and that too with the articulation index and the intelligibility. When we deal with the primary schools children who doesn't know what the word exactly is. So their intelligibility is, that is precision is very important. People like you and me, when we are sitting in a room, yes, when you started architecture course, first year, then you are not oriented with the words or terminologies like say mullion, transom, balustrade, and all these. So that time it was something like starting ABCD. But when you are in third year, you know, okay, Professor Bhattacharya is speaking balustrade. Just catching one syllable of the word, you can find out what is the word. So from your mouth, that is the facial movement, you can get. But we only, so in a conference room, when the context is known, and obviously other participants are contributing. So contributing, you know the discussion in which direction it may go. So you can have some clue from there, and that helps you. So it's good that you are putting in these dimensions. You only can find out the answer that, okay, with some circulation space, effectively, how far are the two speakers? How far can be the two speakers? And then you come out. What is the height of the ceiling? So what is the distance which has been discussed? In 1/10 second, if it can reach, there won't be any echo. So whether it is complying that or not. So that will solve the whole thing. Then whether there is option of treatment to do better, whether to trap sound or not. So those things will come. So this is particularly I'm saying in case of space design, look into the dimensions. What is the purpose? Those are very important. Where is the source? Whether it is multiple source, single source. Okay. No, Abhali, ceiling cannot be completely put with absorbers. Ceiling has to be a reflective ceiling in case of conference room when it is a circular kind of sitting arrangement. What kind of sitting arrangement is also important. If it is a classroom kind of arrangement, then also the ceiling is transferring the sound. If it is a circular kind of a boardroom kind of sitting, everything is one is a chairperson and you are sitting encircling in a circular manner or in an oval pattern, then the central part of the ceiling should be reflective ceiling. So you cannot plan for absorbers there. Absorbers are to be put in the rest of the part. The reflective part means useful reflections. Useful reflections from the furthest end to the furthest end. That will guide your dimension or the periphery of the reflected ceiling. Beyond that, you can put in absorbers. You cannot make it 100% absorbed. Then your sound is gone. The energy is absorbed. You are mute, sir.
Can I add to that?
Yes, please.
Awali, actually the problem is with the reflection, as you told, but ceiling of a conference room is made for reflector, and also you have all glass panels of 4/8 is absorber, and that is maybe a kind of the idea or fashion or something that you should have a look through kind of office space. So only thing is that you have to now have to increase, because as you wrote that your this large amount of reflection is bothering you, and it is about 12 people. So only thing you can do, you can increase the absorber, but you do not have any space left in your wall ceiling, right? So your space is floor, number one. Number two, you can actually use the tabletop. Tabletop also, instead of the glass or so, you can go some kind of velvet or some kind of a soft cloth kind of a thing. You can also use the back side of the chairs. There are 12 chairs, so the back side of chairs you can go and pick up those the chairs which is having heavy fold and have some kind of absorption. You can also go for the drops in the table, the drops in the sense the edge of the tables, which a kind of a for 12 people, which is good enough to give some kind of absorber. So you have to look into some kind of interiors also. Sometimes you may put some flower vase or something like that interior treatment, and effectively you can increase your some paneling. Some space absorber can be used as a interior decoration, and can be used as a absorber if you feel like there need to be improvement in the absorber. So your sense of interior the design should also involve here to improve the total absorption. If you cannot touch the four walls or three walls, and by definitions or by our theory, the reflective panel is actually made for the ceilings. So you have to, if you feel like there is absorber needed, you have to intelligently handle the interior into care. You cannot actually get rid of the reflection from the glass. Glass is a beautiful material as a sound reflector, right? Because it is the properties like that. Even if you just change the roughness of the glass also, it doesn't help, because it is it's a very solid, the solid or hard material. It will going to reflect, and some etching and all also not going to help you. It's not light. A slight small etching or something like that will going to give you diffuse light, but not diffuse reflection, right? Because the lambda, the wavelength of the sound is comparable with the dimension of the glass. So you cannot actually do anything with the glass. Practically speaking, you have to leave it as a reflector only. I think we have only 2 minutes left, because we have to leave by 4:50, because there is another session is on the line, as the NPTEL Kharagpur has told us.
Okay, so mostly it is Abhali and Meenakshi who have put up questions in this live session. Maybe others could not join, and I think they can go through this live session. That will be sent to others. So no, it's a good. We take a note that you had so many questions. That means you are going through the lectures. And okay, another question has come, because we are pressed with time. You have asked how to avoid sound leakage. So various gasketings are to be done to avoid sound leakage. It is like putting some gaskets, like neoprene gaskets, around the glass, that can help you in packing or sealing the sound to get leaked from one place to the other. If sometimes you're playing music and the sound should not go out, again you can have anti-spaces, anti-room, so anti-spaces, so that can actually help you in not allowing sound from outside to get in, neither sound from inside to get out. So those kind of things, I think Professor Bhattacharya, will you be covering in the noise part, noise control part, or vibration, noise and vibration? Or I think in the recording room I have already covered this. I was just wondering. Unmute. Unmute, please.
Airborne sound chapter, definitely I'm going to cover something on that, but not totally what she has asked for.
But already I think in the recording room, if I have
think
covered,
yes.
I think it is there.
Yes,
I have
yes,
already
yes.
discussed.
You
Okay.
actually covered
Yeah,
that portion.
actually the gasketing, you have to put proper gasketing so that there is no leakage. That prevention has to be taken care that way. Other than that, you can have anti-spaces so that noise does not leak inside. That is also important. So it is both way. From outside it should not go in, from inside it should not come out. Okay. That is important, and thank you, Abhali and Meenakshi, to raise so many questions, and this will be available to those who could not join for various reasons, and the time also may not permit others, many of you, to join. Maybe they are having other classes, etc. It is good that you all are posting your questions to mails, and our teaching assistants Monali and Tanya are giving you responses. We are also sometimes they are also taking consent from our side, and then we are also giving our inputs to that. So I think we would should we close it, Professor Bhattacharya?
I think we can close it because only
Yeah.
these two, they have already give us a warning that we have to stop it by 4:55.
Okay.
So only these two.
So I think Meenakshi and Abhali, we will see you in the second live session later, almost at the end of the course. So thanking all other members from NPTEL who have helped us to connect you all. Thanking you all the members of the NPTEL, thanking Tanya and Monali, Professor Bhattacharya, Mr. Das, everyone is there. I think please do this often with more time. Okay, so this is a plan as per the NPTEL, so maybe we cannot, this is a plan from the NPTEL, so we may not be able to get time in this way, but anyway, you can always mail us to any of our supporting staffs, that is Tanya madam or Monali madam or Professor Bhattacharya or me, all of us. We are always there for taking your questions. Hope you will enjoy the rest of the course. Should we leave, Professor Bhattacharya, then? Should we leave? Is there a warning?